All right. The depth of seawater at a location can be modeled by the function h that satisfies differential equation dH dt equals 1/2 times h minus 1 times cosine t over 2, where h of t is measured in feet and t is measured in hours after noon. T equals 0 when it's noon. It is known that h of 0 equals 4. H of 0 equals 4. A portion of the slope field for the differential equation is provided. Sketch the solution curve y equals h of t through the point 0,4. This will probably, when the scoring rubric comes out, get you 1 of your 9 points. And y'all, if I taught you this and you couldn't get this 1 out of this 9 points, because this is what I'm fixing to do. And that's going to earn me 1 out of my 9 points right there. Just sketch an approximation of the curve. That's all that slope field tells me. All right? That right there, 1 out of 9 points. B says, for 0 less than t less than 5, it can be shown that h of t is greater than 1. Find the value of t for 0 less than t less than 5, at which h has a critical point. Determine whether the critical point corresponds to a relative minimum, a relative maximum, or a relative minimum, or neither a relative minimum nor a relative maximum of the depth of the seawater at that location. Justify your answer. Okay, we're going to do part B up here. So critical points happen where the derivative dH dt is equal to 0. So in this case, dH dt equals 0 when h equals 1. Would you agree with that? Right here, if I plugged in 1, that would make that 0. All right, we're on the interval from 0 to 5, or when t equals, now when I get this, I'm going to make cosine t, or cosine t over 2 has to be 0. So this is going to be at pi. And the next time it's going to happen is at 2 pi. It said greater than 0, right? But 2 pi is not in our interval from 0 to 5. 2 pi is greater than 5. Would you agree with that? So this is the only 2 critical points, when h equals 1 and when t equals pi. So I'm going to check that out. Let's see here. H of 0 is 4. H of pi is equal to, we don't know what h of pi is. We need to figure out what's going to happen here. I'm going to make a sign chart. This is going to be t, and this is going to be dH dt. When t is 0, let's see here. This says that h of t is greater than 1 on this interval. So we don't have to worry about this part, because that's when h is 1. Here, we're looking at 0, pi, and 5. The intervals. So here is where, this is where dH dt equals 0. So I need to figure out over here, h is greater than 1. That makes this positive. H is less than pi. Cosine's positive between 0 and pi over 2. So that makes this positive. And then when we get bigger than pi, cosine becomes negative because something bigger than pi over 2, cosine is negative. H is still greater than 1, so this is negative. So that means determine the critical point corresponds to a relative maximum. All right, we found the critical point. That's here. And so now we're going to say dH dt changes from positive, I'll move right out, to negative at t equals pi. Therefore, h of t has a maximum. Maximum at t equals pi. And that's part B. Part C says use separation of variables to find y equals h of t, the particular solution to the differential equation. And this will be the biggest part of this for points-wise probably. So separation of variable means we're going to get everything that has a t on one side, everything that has an h on the other side. So I'm going to divide everything by h minus 1 and get dh over h minus 1 equals 1/2 cosine t over 2 dt. And now I'm going to take the antiderivative of both sides, and this is going to give me the ln of the absolute value of h minus 1 equals, and this is going to be negative sine t over 2 plus some constant c. Let me double check that and make sure. I've got 1/2 dt, it's cosine 1/2 t, and if I let u equal 1/2 t, du dt equals 1/2, so du equals 1/2 dt. So that makes this the integral of cosine u du, which is negative sine u. Sorry, positive sine u. Positive sine u. So sine t over 2 plus c. Now we know that h of 0 equals 4, so if I plug in 0 for t, and I plug in 4 here, ln 4 minus 1 equals, this is going to be sine 0, that's 0 plus c, so c equals ln 3. So my ln h minus 1, and h is known to be greater than 1, so I really don't need the absolute values. I'm going to leave them there for a second though. Equals sine t over 2 plus c. I got to solve this for plus 3, ln 3. ln 3, we already solved that. So I'm going to raise e to both sides. I'm going to get e, sorry you can't see that, to the e to this side equals e to this side. That makes this h minus 1 equals e to the sine t over 2, properties exponent says times e to the ln 3. E to the ln 3 is 3, so that's going to equal 3 e to the sine t over 2 plus, I'm going to add 1 to both sides, plus 1. That's my h of t. That's my particular solution. That shouldn't have been too hard, but anyway, that wasn't too bad. That's the end of that one.